All right, thank you for joining us today. And this is the last video on let us practice by finding the inverse of a function. So in the next video, we are going to talk about using the inverse function theorem to find inverse derivative and to find the derivative of a function, which is also going to be so interesting journey that you can go through. Like we are going to learn the steps and everything. So now let's focus on now doing the last example on inverse of a function. Let's jump right in. So find the inverse of the following function, right? So A, we want to try this one. Okay, so let's try by finding. So the first thing that we need to do is we need to let y to be equal to our function. Interesting question. You can pause the video to try, or you can go through this one, then the next video you pause it and try. So what we need to do here is we need to interchange x and y. So interchange x and y. 4 minus 3y plus 2, right? Then we need to make y the subject. So first thing that we need to do is we need to subtract 2 here. We need to subtract 2 here. So we are going to have x minus 2, which is equal to log base 5, then 4 minus 3y. So in the previous video, we saw when we have an exponential function here, like something like 3 to the power negative 2x plus 1. Then what did we say? We said we need to pick, log on that. So now, if I have 3 to the power, let me say, if I have 3 to the power a, and I need to take log of a on this, then log of 3 on this function, then it means that when I have the log, I need to take the one in the bracket. So it's very simple. Listen, just pay attention here. If I have log of, let's say, a, right, or let me say if I have a to the power m, and I'm saying that for me to find m, I need to pick log of a, right, log to the base a. So why am I picking log to the base a? Because the base here is a. That's the reason why. So now, if the question is given to me and I have this one, then what should I need to do here? What I'm going to do is I'm going to pick something like something to the power so that I can cancel this one. So here, what we want to do is we want to try to find the antilog, right? We want to find the antilog of this. Because remember now here, when I move the m, I'm going to have m log of a base a. So now since I have this guy here, then I need to pick the antilog of a. Then I used to do that. So now let me try and show you what I was trying to talk about. So since this is base 5, I'll pick the antilog 5. So I'll have it to be exponent. So you see what is happening here. You saw that whenever you have it in this form, you need to pick log to the base 5. So now since we have log to the base 5, then we need to pick 5, like exponential function. So this is going to be 5 log 5. And then this one will be 4 minus 3y. That's very nice. So what we are going to do is, this is going to give us 5x minus 2, and this is going to give us 4 minus 3y, and then we are going to have 5 log 5. Now this right here is going to give us 1, so we are going to have 5x minus 2, which is equal to 4 minus 3y, all times 1. See how beautiful math is. So now 5x minus 2 is equal to 4 minus 3y. Then by making y the subject, what we can do is I will add, because this is minus, I want to add, okay, so let me focus on this one. I want to add minus 4, or by still I'll move this one here so that it become positive. So I want to add plus 3y here and plus 3y here, right? So when I do that, I'm going to have 3y, which is equal to, now remember we didn't move this one, So we still have the 4 here. Then what I'm going to do is I'm going to subtract x minus 2 here so that it will cancel this and subtract 5x minus 2 here. So I'll have minus 5x minus 2. So the idea is move this one here, which becomes positive, and then move this one here, which becomes negative. By making y the subject, we need to divide both sides by 3, and we are going to have y to be equal to 4 minus 5x to the power 5 to the power x minus 2 divided by 3. So this will be the f inverse of the function. So f inverse of x is 4 minus 5x minus 2 divided by 3. So very simple. So don't forget what we just did here, how we raise the power function here. All right, let's take the b. So now we are done with this one. So let's look at the b. Okay, so b, let's go through the process. You can pause the video to try. Y is equal to ln of negative 3 plus 4x, right? Then we need to interchange x and y. So x is equal to ln minus 3 plus 4y. Good. Now remember, we solved one example in the previous video where we were having e to the power say a, and I said we need to take the ln. So it means that if I see e and I'm taking ln, then when I see ln, I'm going to take e. Is that right? So it was like the same thing as this one, right? But here, because we are dealing with ln, we need to take the e, right? So this one is going to be e to the power x to be equal to e to the power ln of minus 3 plus y. Good. So e to the power x is equal to negative 3 plus 4y, then e to the power ln. So this one is like there is 1 there, so you can decide not to bring it. So this is going to be negative 3 plus 4y times 1. So e to the power x, this is going to give us negative 3 plus 4y. By making y the subject, add 3 here, add 3 here. Or move the negative 3 to the left hand side, which will give us e to the power x plus 3, which is equal to 4y. Let's divide this one by 4, divide this one by 4, and y is equal to plus 3 divided by 4. So this is the gene inverse of x, which is equal to this plus this divided by 4. Very simple, right? So let's take last video on this, and then we go ahead to go and look at the inverse function theory. Last example. So we are done with this one, we are done with this one. Let's try this one. Oh, that was nice, right? So let y to be equal to 5, 4 plus 4x divided by 5, 2x plus 2. Yes, so I heard somebody saying, yes, we've done similar example before, yes, where the base are what the same. So we need to apply the law of what indices, which says that if I have a to the power m divided by a to the power n, since the base are the same, this is m minus n. So that was the first thing that you need to look at. So now we are going to have y to be equal to 5, 4 plus 4 minus. So as I said, as soon as I write minus, I need to make sure the function that I'm going to write is in parentheses. So y is equal to 4 plus 4x. When I multiply the minus 2, I have x, I have that. So y is equal to 5. Now this and this will be 2, and this will be 2x. So we are going to have 2 plus 2x. Good. So since now we were able to simplify this, what we are going to do is we interchange x and y and just solve for y. So we've done this before. So we need to take log to the base 5x. I hope right now you understand the reason why we are taking it, because this is 5 and it's an exponential function. So we need to take the log but to the base 5. So log 5 5 2 plus 2y. So log x is 5 is equal to 2 plus 2y, log of 5 and 5. So log of x base 5 is equal to 2 plus 2, and log 5 base 5 is 1. So now we are going to have log of x 5, which is equal to 2 plus 2y, and then we subtract minus 2, we subtract minus 2, or we move 2 here, which becomes negative. So log of x base 5 minus 2 is equal to 2y, right? Then we divide both sides by 2, then we are going to have y to be equal to log base 5x minus 2, all divided by 2. So this will be the h inverse of x. H inverse of x. Log x is 5 minus 2, all divided by 2. Good. So this is the last example on this video. So in the next video, we are going to look at one of my favorite, math theory, using the inverse function theory. It's very nice. I'll show you all the tricks, everything that you need for you to, go through, right? So see you in the next video.